like that. And as this technology develops, it's expected that the devices themselves will be very cheap. So people envision using hundreds of them in environmental monitoring applications. Now, what differentiates this technology from standard embedded computing is since we are not going to be able to plug these into the wall, they actually are always battery operated. And communication, as you may know, consumes a lot of energy. I mean, if you turn on the wireless on your laptop, its battery dies much more quickly. So when we develop algorithms, the algorithms must be, in a sense, energy aware. Now, some of the demos that you're going to see today is about that. Now, what we focus on is actually using robots to automate some of the sensor network tasks. So one project we have is in environmental monitoring. So people are interested in monitoring carbon dioxide and nitrogen and humidity level in soils. So they want to put lots and lots of sensors in a large environment, say in a forest, and we would like to be able to collect the data on these sensors using robots. Now, to consume the energy spent by these devices, it is actually good for the robot to find a good location to download the data because the signal quality changes drastically from one location to another. So one demo will be that, and we'll see that later, which is, the robot will search for a good location where it can get nice signal strength and download the data from there. The other two demos you're going to see are about the specific robots. Since we want to be able to do this outdoors as well, we're developing some robots. This is, as I said, in Professor Papanikolaou' lab, it's developed there. And this is something we just started developing. It's actually based on a toy monster truck, and we're putting extra sensors and mirrors on it. So who is going to go first?
Let's talk about the local first.
Okay.
So the LOPA has been, as Professor Isler said, it's more of an outdoor platform. As you can see, it's like a big thing with like strange looking wheels. The idea of the wheels was basically making the robot able to go upstairs. So unlike the Packbot you just saw, right? The Packbot had threads. Here you have actually those tri-load wheels. You probably have seen those things on like carts, where you have like those three-wheeled carts to go upstairs. Probably, maybe. So that's where the idea for that came from. And yeah, so a grad student of Nikos has built that, and unfortunately at the moment there's no real computational power on it. So it doesn't take any decision. It's basically just a robot, and to move it around, Ono will just like send commands to it through a computer. But the basic idea is we have a miniaturized computer, so it'll fit in this spot here, and it'll be able to do basically, or the idea is it'll be able to do the same things as Ono is going to demonstrate driving it.
So here I will just show that like we can control the robot just going forward from this laptop. And in the future, we want to put like more sensors, laser rangefinders, cameras, or IR sensors, so that the robot can navigate in harsh conditions, like outside environment, autonomously. So I will just show that how we do it.
So now the speed is actually turned down way slower, right? So it can actually move faster than that, but in order to not hurt somebody or to break the robot, we make it move slowly. It's basically at the moment just to prove that it moves, so that you can see that it moves. If you want to see like the LOPA actually going through rough terrain outdoors, you can look the videos up on YouTube. There's a video posted on YouTube, so just go to YouTube and search for LOPA. So you'll see that.
Could you have that make a corner?
Yeah, so basically, as you see, it goes forward while when you have like all the wheels, all the motors going in the same direction, right? Then you can actually make it turn on the spot when you have like it's like it's almost like a tank steering,
So
right?
each wheel has its own controller, so you can like control them separately. But as of now, we are just setting what all the wheels to same speed and same rotation. So it goes like smooth and straight. We can do whatever.
So no, we haven't programmed that. So at the moment, it's just basically just does that. Doesn't do too much, but that's all like a thing of programming, right? And since it's just at the moment just to demonstrate that it moves, the idea is to actually have it later do stuff like movement by itself and like intelligent movement, basically. So I think
That's all we want to say.
that's all we want to say about Lopo.
Is that mechanism something that you built, or is that something you purchased?
No, the Lopo was completely built from scratch.
Okay.
Yeah, it's
So the design is belong to that grad student who is graduated before we came
yeah.
in.
So he got his master's thesis for building that. Yeah, and unfortunately he left. So sometimes it's difficult to get in touch with him.
What's the name? Lopo?
Lopa, L-O-P-E-R.
Oh, Lopo.
But I think what makes it special is the wheel design, right?
Yeah, so it was specifically designed to go upstairs. As you could see on the packboard, it's difficult for threaded robot to go upstairs. And with these kinds of wheels, that it actually makes it easier, right? You can easily imagine if you have a step that is like this high, it'll still be able to get on top of it because like it catches the edge and then it just kind of pulls itself up.
So it was stepper motors?
Sorry?
Stepper motors?
Yeah.
And the other thing is if it flips over, it doesn't matter. You can just continue.
Yeah, so at the moment it doesn't matter which side, but later on maybe we'll put like sensors or cameras on it and then it'll matter. But at the moment we can like go whatever way suits us. You guys have any other questions maybe? I guess then, do you want me to take that out of the way?
Sure, yeah.
Is that a complete chain all on one side and the other side connecting all the wheels? Oh, okay. There's no chain.
It's under.
Yeah, I thought the
Which case it could smooth.
Yeah. Like, yeah.
Want to take over? Yeah.
So those white robots are actually based on the Roomba vacuum cleaners. These are the educational versions of those without the vacuum cleaner parts.
No, we just did this to control the robot.